Hey guys, welcome to my class Python for Beginners, and today we're going to talk about tuples and dictionaries. So tuples are used for grouping data. We saw earlier that we could group together pairs of values by surrounding them with parentheses. For example, so we say that details the variable and assign it something within parenthesis, and let's say I put my details inside this value. So these are my details, and this thing is called a tuple or a tuple, and it's a group of data. Now hit enter, try to print details, and these are my details. You can access my individual details using the bracket notation. Details 0 is Amit Gupta, details 3 is male, length of details is 4. Similar to lists and string. Tuple is also immutable. So let's say there's some wicked guy who wants to change my gender on a record. I don't know, can be some foolish guy who has something against me, and he says details 3, I wanted to change it to female. Haha, Python comes to my rescue. It won't allow you to change my gender. I am male, I will remain a male. Tuple object does not support item assignment. When you say type details, so it is of a type tuple. Okay. So now there's something called a tuple unpacking. So it looks like, let's say I have 4 variables for the 4 values inside the tuple details, and I call them name, year of birth, age, and gender, and I assign this the value of the tuple details. So if you try to print name, this is Amit Gupta, try to print year of birth, it's 99, try to print age 23, gender is male. Now this shows that the values of the tuple details were unpacked into the corresponding values on the left of the assignment. Alright, now tuple assignment solves the problem of swapping variables really easily. For example, let's say you have a equals to 5 and b equals to 6, and you want b to hold 5 and a to hold 6. One way to do this is through tuples. PA. Now a is 6 and b is 5. So the left hand side is a tuple of the variables, the right hand side is a tuple of values. Each value is assigned to its respective variable. All the expressions on the right hand side are evaluated before any of the assignments. This feature makes tuple assignment quite versatile. Alright, let's talk about composite data structures. So a list can have any elements, lists can have tuples, tuples themselves can have lists, and so on. For example, let's open our new file today and we call it Python. Okay, pasting some code here. Oops, sorry guys, I have a composite data structure already written in my notes. I'm going to paste it here. This is the data structure. So this data structure shows you that the students is a list of elements where the elements are of type tuple, and each tuple has 2 parts. First is the string, which is the name, and second is the list, or the subjects which a particular student is undergoing in a particular semester. So if you print students 0, this will give you the detail of John. Let's see, there it is. If you say 0, 1, it will give you the subjects with John is studying. If you say student 0, so don't get scared by this. Student 0 is a tuple, and now if you consider this as a tuple, you can use the indexing on this particular tuple to access its individual elements. If you say 0, it will give you the name, and so on. Now functions can always have only, or rather functions can always only return a single value, but by making that value a tuple, we can effectively group together as many values as we like and return them together. This is extremely useful, guys. For example, let's take a function, call it multiple return. What it does is it takes the radius of a circle and returns both the circumference and the area. So now you can return circumference of a circle, which is 2 times the value of pi times radius. The next quantity is the area. Area is pi times r square. And now you call multiple return on, let's say 5, and it gives you r is not defined. R, sorry guys. Okay, got to print that value as well. Okay, so 31.4 and 78.5. Okay, so the next topic for today is dictionaries. So all of the compound data types we have studied in detail so far, strings, lists and tuples, are sequence types which use integers as indices to access the value they contain within them. Dictionaries are yet another kind of Python type. They are Python's built-in mapping type. They map keys, which can be any immutable type, to values which can be any type. Just like the elements of a list or a tuple can be the values, but the keys have to be immutable, can be only strings or numbers or tuples, etc. In other languages, they are called associative arrays, since they associate a key with a value, or hash tables. For example, we create a dictionary now to translate English words into Spanish. For this dictionary, the keys are strings. So one way to create a dictionary is to start with an empty dictionary and add the key value pairs. The empty dictionary is denoted by so the empty dictionary is denoted by, let's call this dictionary English to Spanish. This is the empty dictionary denoted by curly braces. Okay, so now we start adding terms to it. Now, unlike lists which we index using integers, this dictionary I'm going to index using the keys, and my keys happen to be strings. So one is eng to sp, 2 is to be translated as dos. So now you print your dictionary and looks like 2 is mapped to dos, 1 is mapped to Okay. The first assignment creates a dictionary named eng to sp. And the other assignments add new key value pairs to the dictionary. The key value pairs of the dictionary are separated by commas. Each pair contains a key and a value separated by a colon. Another way to create a dictionary is to provide a list of key value pairs using the same syntax as the previous output. For example, you can also say that I want a new dictionary, and which is equal to, within curly braces, the first key value pair is 1 mapping to 2, the second comma, second key value pair 2 mapping to DOS, and now you print you take just 2 DOS 1 only. Alright, so it doesn't matter what order we write the pairs. The values in a dictionary are accessed with keys and not indices, so there is no need to care about ordering. So here is how we use a key to look up a corresponding value. For example, if you want to check what is the mapping for number 2, it is DOS, and if you enter something invalid, let's say we haven't put the number 3 in there yet, and you try to access it, it will give you an error, key error, because this key is actually not there yet. Okay, now we'll turn to some dictionary operations. So the delete statement removes a key value pair from a dictionary. For example, let's take example of a dictionary which is an inventory of fruits. For example, we have our inventory, which is 430 apples, 312 bananas, 525 oranges, and 217 pears. Okay, first you want to print the inventory. This is the inventory. Now if somebody buys all of the pairs, we can remove the entry from the dictionary. For this, we say delete inventory pairs, delete all the pairs, and print inventory. There are no pairs now. Or if you are expecting more pairs soon, we might just change the value associated with pairs. For example, we can say that inventory pairs is equal to 0. Now you print inventory and it has 0 pairs. Now a new shipment of bananas arriving could be handled by saying something like inventory bananas plus equals to 100. So 100 more bananas are going to come. Now you print inventory, which is 412, 100 more than the previous one. Again, the length function also works on dictionaries, and it tells you how many key value pairs are there in the dictionary. Okay, now let's look at some dictionary methods. So dictionaries have a number of useful built-in methods. Keys, one is a method called inventory.keys. It's called the keys method. It gives you pears, apples, oranges, bananas, basically all the keys that are there. Similarly, inventory.values method gives you all the values there. So the keys and values method have some similarities to the range object which we saw earlier. It's a lazy promise to deliver its elements when they are needed by the rest of the program, so we can iterate over them. For example, for x in eng2sp dot values, you say print x, and DOS and uno are the two values, but for x in eng2sp dot keys, you want to print x and I use the key instead of keys. Two and one. Alright. Also, you can do something like, you can say KS is a list of the values in the dictionary. And what is KS now? KS is a list. So you can say, but if you said KS is equal to eng to sp dot values directly and print KS, this works as well. So it's the list command will basically take a sort of a sequence and make a list out of them. For example, the KS is list 1, 2 and 3. It takes one argument. So basically you have to provide the list a sort of an object which can be iterated over, and list will convert that into a list. We'll see example of that maybe a little later when I talk about sets. But you should remember this command list takes in one argument and converts it into a list. Okay. For example, it took the value eng to sp dot values. This will return an object which has the values and it can be iterated over. So the list takes them and creates a list out of them. Alright. So we can actually omit. Did you see that? When you issue a list on empty, it creates an empty list. Alright. Okay. Now you don't actually need to iterate over the dictionary. You don't actually need to say eng to sp dot keys. You can just say for keys in eng to sp, or rather for key in eng to sp, I want to print the key, and it gives you the various keys. Okay. So the items method also works on dictionaries, or rather the items method on dictionaries is also a sort of a promise, and a promise is a list of tuples. So this promise I'm going to give it to the list function, and I say eng to sp dot items. So all the items, take them from the eng to sp dictionary and convert them into a list, and it's a tuple now because the items are a key value pair. So it's formed in the, it's converted to a tuple form and concatenated to get a list. Okay. Then there are the in and the not in operators to test if a key is in the dictionary. For example, you can say 1 in eng to sp, and that's true. 3 in eng to sp is a false, whereas 2 is in the dictionary, which is true, and the not in is similar. So if you say 3 not in eng to sp, this is true. So this method is useful because looking up a non-existent key in a dictionary causes a runtime error. So eng to sp 3 is a error. So if you don't want that error to be thrown, because once your error is thrown, your program terminates unless you have caught that error, which we'll talk about again in a later class. So you don't want your program terminate, so it's better to check if a key is actually there in the dictionary or not before you actually access that key. And guys, know that the in and the not in tests the keys and not the values. So I want to end this class right now. Next class we're going to talk about sets and list comprehensions. So guys, stick around, take care and keep up the hard work.